Hypothesis test for the population proportion. A hypothesis is a conjecture about a population. In terms of statistics, it will usually be a statement about the value of a parameter, such as mu or p. A test of hypothesis is a statistical procedure or a process used to make a decision about the conjectured value of a parameter. It involves making a decision between two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis, denoted h sub 0, specifies a value of a parameter. This hypothesis is assumed to be true, and an experiment is conducted to determine if the collected data is contradictory to the null hypothesis. We will write this statement as h0, the parameter equals hypothesized or assumed correct value. Example, h sub 0 might be p equals 0.25 for 25%. The alternative hypothesis, h sub a, sometimes also written h sub capital A or h sub 1 and other resources, gives an opposing statement about the value of the parameter. The collected data will be analyzed to see if it supports the alternative hypothesis by casting doubt that the null hypothesis h sub 0 can be correct. Specifically, we assume h sub 0 is true and determine how likely or unlikely the sample data would be under that assumption. If the sample data would be unusual to observe, and we just observed it, then we reject the idea that h sub 0 is correct. A test statistic is a quantity calculated from the sampled value of a statistic, which is then used to calculate a p-value, a probability, for a test of hypothesis. The z-score will be used as the test statistic for a proportion. The p-value of a test of hypothesis is the probability of obtaining the observed value of the sample statistic, or one which is even more supportive of the alternative hypothesis, under the assumption that the null hypothesis is true. In other words, if the null hypothesis is true, how likely is it that we would get this particular sample data or something which is even more contradictory of the null hypothesis? The decision rule. We make one of two decisions, often called the conclusion. If the p-value is large, this implies the sample data is typical or common or not unusual, and we decide that we fail to reject the null hypothesis. It could be true. If the p-value is small, this implies the sample data is unusual based on the value used for the parameter, and we decide that we will reject the null hypothesis. It is likely not true. HA, the alternative hypothesis, is more plausible. The decision rule just tells when we say the p-value is small enough to believe that HA is true. This value we compare against is called a significance level or alpha level in a hypothesis test. We will discuss it in more detail later, but for now it will be a value such as 0.01 or 0.05 or 0.10. It may also be given as a percent, such as 1%, 5%, or 10% significance level. The rule will state, reject H0 if the p-value is less than or equal to alpha. The summary. For this class, you also need to add a statement that summarizes your findings. It will involve an interpretation of your findings. It must give information including the level of significance used to make the decision, what the parameter is for the scenario, and if you support the statement for the alternative hypothesis. The format will typically be something like the following. At the 0.01, 0.05, or 0.10 level, or level of significance, there is or is not significant evidence to conclude the proportion or percentage being examined in the particular scenario is maybe greater than, different than, or less than, depending on what the alternative says, the value in H naught. But you're going to enter the actual value. When asked to verify the hypothesis test is valid, you'll refer back to the conditions which allowed the treatment of the sampling distribution's proportion to be well approximated by a normal curve. So 1, a random or representative sample is taken of categorical data. Second, n times p is 10 or more, and n times q, or n times 1 minus p, is also 10 or more. So the steps for a hypothesis test about a population proportion include 1, define the parameter of interest, 2, identify the null and alternative hypotheses. Here's a hint. H sub A, the alternative, defines what the researcher is trying to prove or support. 3, set the significance level, alpha equals what number, and give the decision rule. 4, check the validity conditions, informally if not asked to do so, or formally if asked. 5, give the formula to obtain the test statistic, then calculate the test statistic based on the sample collected. This will be your z-score. 6, calculate the p-value, the probability, based on the observed z-score and HA. 7, make a decision. Either reject the null hypothesis, H0, or fail to reject H0. Finally, provide a summary, and remember your summary will include the level of significance, the parameter and what you were trying to prove about it, and whether you did or did not have significant evidence to conclude that final statement.